Hello and welcome, fellow Patreons or YouTubers, or how you want to call yourself. This is my attempt to show you my try to build the Carlsons Curve Tracer. And I will show you some pictures of it, and we'll talk a little bit about the problems and the hints, and some design quirks I have to do to make it able here in Germany to build this nice, neat project. These are the agenda. My English is not so good at the moment. So at first I want to give a quick view why I built this project, and then go over to design thoughts and problems. And then I will talk about what I've changed about this nice project, or this is not the same project as Mr. Carlson put it out, and then afterthoughts, what would I change and do. So yes, let's have a little look what's going on in the next few minutes. Hello, fellow Patreons or YouTuber or what else you want to call yourself. This is my attempt to show you my project of the Carlsons Curve Tracer project. In these following minutes in this video, I want to talk a little bit about my build of this curve tracer. It took me a fair amount of time to build this, because I have to get hold of all the tools and the techniques and money and etc. etc. Because I have not great space and money. I'm a student. I'm going to be a teacher, and so time was also a very difficult thing about this project build. But let's dive in the project. I want to address some points on this curve tracer, and the first thing is why I built this project. Next thing is design and thoughts and problems. It's especially problems with getting parts or getting part that fit and that can be used with it. What I've changed during the process of building this curve tracer. And next thought or last point is what would I change in the future if I want to build it again. And yes, I would say we should begin with some pictures and some explanations and why I built this project. I built this project for not for a particular reason. I built it because I wanted this neat device, and I want to show you some of the pictures and talk with you about that. So this is the front of my curve tracer. As you can see, it has a BNC connectors to the oscilloscope. Later on the pic you will see what oscilloscope I will use, and you'll see the big dial knob over here and the switch for the high current and low current, and some connectors for the probes. So the first point why I want to build it, I want to build this neat device. I thought it's quite nice to have such a device, and to have to probe in circuit and find out what particular component is in front of you. So I thought, well, it's quite easy to build. I want to learn how to add PCBs. I want to build it all of on my own, and I want to do it all by myself. So not just getting over and order a PCB or sending Gerber files to a PCB manufacturer. I want to do it myself, so I can I can say, oh, look, I've built this by myself. I'm such a nice guy. No, this is why I built it, and I thought it's would be wonderful to do that. Yes, you think you see this project is an enclosure because I don't want to build it into an existing oscilloscope, because I have two analog oscilloscope that are quite good and I don't want to open them, and I like the look and the feel of the project now it is put together. We can look at some pictures over it, and you will see some nice quirks and something else. So in the front there's a big knob, and the dial that goes up to 11. Everyone who knows Spinal Tap, you have to put up a dial with 11. There's no way around an 11 on a not to put a 11 on a dial. So it's obvious to do that. I choose for this for the probes nice Hirschmann connectors. You can get them in Europe. I think they are leading manufacturer of probe connectors here in Germany. They are very, very good and beefy. You will see in a next picture. They are very good, very tight. And why I choose this style of connector, because I want to use my existing probes of my digital multimeter, my Bryman BM235. I like them very much and I want to use them, and because of that I chose these rather expensive connectors, but they are worth it. I choose this big knob because I like devices with big knobs. So for obvious joke reasons, you can say big knobs are always a good choice. So let's get further. Yes, this is a look in front of it. You can see the BNC connectors. Maybe these ones are not the best. They are quite cheap, but for this kind of job with 1 kilohertz of signal, I think they will work good in a long time. This is my back of this of my device. I put a switch in it because I'd like to switch on and off my devices, even to put a fixed line into it or a fixed cable into such a device. I want to disconnect it because my space on my desk is very, very, very little, so I choose this option. The same Hirschmann connectors for the connection to the multimeter. I use my Bryman 235 for it, and it works like a treat. I also liked really this enclosure. It's made of plastic, or we like to say in German, of Kunststoff. It's quite sturdy, and the PCBs fit in it very nicely, as you can see on the next picture. So this is top off of my project. As you can see, I've changed something, and this is what I want to address. Over here I've used on shrinking tube on every wire, on every cable, because I think it is very, very important to have a safe device, and if someone else want to use this or open it, I will never have to say, oh, they can electrocute themselves. Even now it's very hard to electrocute themselves at this project. And now I want to, if you can't see it, there are some changes at the PCBs, and the main changes are these connectors, the main connectors. What are screw terminals with a pitch of 10 millimeters, because we are here in a country with metric. And I added another transformator. Well, how do you say in English? I don't know right now, because this transformator suit this project wonderfully. It works like a treat, but I have to say something about this again later. So these are the two big changes of my project. I have to adapt the PCB to put these screw terminals on it and the other style of transformator. So another problem appeared over time. The PCB of Mr. Carlson with these trimmers over. So another element I've changed is the footprint of these trimmers, because Mr. Carlson used trimmers with imperial footprint. I can't get an imperial footprint over here in Germany, so I used metric ones, and they have another spacing between the footprint, and I've changed it. And now you'll ask, Matt, how do you change the PCB? And it's quite easy. As a friend of mine said, you can Photoshop everything or you can GIMP everything. I've done it with GIMP or Photoshop. This is the adapted one, because between this and this one are 10 millimeters. This is the depth one. We can measure it, so you can see it between these two legs. There are 10 millimeters, and if you want to see over there, this is something between I think 5 millimeters. Yes, it's about 5. That should be right. So I've changed all the trim pots with Photoshop, but I'm able to use my trimmers, my European trimmers, with a footprint of 10 by 5 millimeters. I have to edit it all over here, over here, over here, over here. And maybe I can show you the other ones that are not adapted. This is the original one of Mr. Carlson, and if we measure here, we will see it is not 10, it is 8.8 or something in between. You can also drill the holes further apart, yes, but I wanted this clean solution for myself, and it brings me some and over here it's 4 or 6. You can drill it. It's absolutely possible to drill these points and have a good time, and it will work. I want a clean solution, so I've changed all. And also I have changed this this pattern, because I use a transformer with a single coil and not like Mr. Carlson with a double coil. So I have to change this footprint to be. You can see the changing that I've made. This is the original one, and here you can see the double coils, and I changed it for my PCB for this transformator. This is 20 by 20, so 20 between these. You can also measure it, and it's 20, and this is also 20. You have to go by here, and you can see, I don't know what's called in English, but in German it's the Rastermaß. It's a standardized measurement for these transformers, and it worked out very, very, very well. And as you can see in my pictures, you can it fits wonderfully. So the next topic I want to talk about is a transformer, and it was quite a hassle. I done not my math properly, and I have ordered a wrong one. So as I said, I've not done my math properly with my transformer over here. Now it's geared 304.18 1.8 VA, and it has on the primary side 230 volts, 50 to 60 hertz, and an output of 100 milliamp, 18 volts, and it works like a treat. In first moment, I used another transformer, but this was not the best choice. I've ordered this one. This is a block transformer, German company. I purchased all my parts over Reichelt Electronic. It's a local German supplier. You can get there. Germans will know who is in Germany and will doing electronics and DIY will know Reichelt. It's one of the big suppliers here in Germany, but you can't get as much parts at DigiKey or Mauser or Farnell if you want. But as a private person, you can buy their stuff, and this was my choice, my my source of choice, my choice of source. I don't care. At first I ordered this one because I thought, oh, this Motorola 1468 have 100 capability of 100 milliamp, so I choose a 155 milliamp transformer to have a little bit more capabilities in the transformer. That was not the smartest choice, cause I don't thought about I don't know how you call it in English, but we know it like Leerlaufspannungsfaktor. So if there's no load on the transformer, you have a problem because the voltage is going to be up. So we have an output of 18 volts AC, and the factor you have to multiply this is 1.31, and if you multiply it with 1.31, maybe you I have to calculate it. 18 multiplied by 1.31 is 23.58 volts, and the Motorola chip have input voltage up to 30 volts. So 23.58, you think, oh, it's quite nice, it's good. But the next problem is we rectify this voltage, and after this rectification, you have the problem. You have to these 23.58 volts. You have to multiply with the square root of 1, and you are far over the voltage of the regulator. You're 33 volts or something like that. So my first regulator, I tried it. I fried my first regulator, my MC1468, and wrecked one. But I ordered 4 of them. I knew I'm gonna destroy one, so I destroy one. So this transformer is not your choice, and you have I have to look after another. And after this, I thought, okay, let's have a look. And this one this one works perfectly. It nearly it's a printer of the Gerd company, and it's 18 volt, 100 milliampere. The chip is able to put out 100 milliampere, and this works wonderful. It's nearly 28, 29. After measuring behind the rectified diodes, you have 28, 29 volts. It works without a load perfectly, and will not fry your chips. So this is a design choice by myself, because I can't get these transformer Mr. Carlson used, so I used this one, and I'm quite happy with it, and it works like a treat. Yes, and this was the one choice I have to make, and another choice was equally made. This was with the screw terminal, because I want this as a safety feature, that you can unscrew it and have not to solder it. I don't like to solder main voltage down. Yes, it's safe in consideration of mechanical strain, but this solution offered me a nice way not to contact any other things, and I'm able to have a double insulation here. Over there you see all the shrinking is done nicely, and I hope this is safe for everyone who opens it and everyone who knows what he does and do. And you can see, okay, over there must be high voltage, so I used also the cables over here with the right colors. And yes, it works wonderful, and you can see the trimmers also worked wonderful. So these are the main changes I made to this project, and they worked out fine, because I want this extra portion of German safety madness, you maybe can call it. Yes, I think this is this is the right choice, and it's works out very fine. Here you can see the nice beefy Hirschman contacts. These connectors are worth its money. For good connectors. Shitty connectors are always not so nice. So to recapture is, what have I changed? I would say I've changed the footprints of my trimmers, the footprints of the transformer style, and that's are the main big changes on my PCB. I have to admit, these spacing is a little bit tight. I have to put the connector over here and solder it somewhere else. These spacing have to be bigger, cause the transformer, I've chosen the GERT or the GERT to pronounce it correctly German hard, have another footprint or slightly other dimension, outer dimension than the block transformer. So what would I change? I would change probably nothing. I just want to change the footprint of the wire connector. In general, I would change nothing. This is my setup in work. You can see I've connected it with some nice 316 coax cables and some connectors. It's heavily over-engineered, but I like the look, I like the feel. It looks like professional work and professional measuring. It can be done easier, it can be done I know, but this is what I like, and I think it looks gorgeous. I bought some BNC cable 10 meters for €7 and a crimping tool for it for maybe €9, and it works like a treat. It was simple. Over here you can see my Bryman multimeter, and this is a setup I really use, and you see my space is very, very, very small. I have to put it up to on my amplifier, and you can see it's quite cold outside. My amplifier has a little head on his knob, because that he can't get a cold. So and you see over here in the other corner there's my rival oscilloscope. So it's very, very a little space, and the curve tracer is now portable. I like that design very much, because I can stand over it, and I've thought many, many times where I put the dial and where I put the probes, and it's kind of difficult to figure it out because I'm a right-hander and I want to hold probes in the right hand and want to dial in the voltage on the big knob with left and something like that. Yeah, that's what on the how to lay out these front PCB. There went a fair amount of time in it to do it, because you have to consider some points. How do you switch the current? Are you get it is it able to do it with probes in or not, and where do you want to put the switch so you can do it easily, cause nothing bothers more than a bad front design or front end design for a device, if it is physical or it is not physical. A bad design front end always is not so nice to work with. So there went fair amount of time to put these connectors like this, and I like it very much. And this it works wonderfully. My probes go in very well, and I would make it the same, and the layout and the design, yes. And for anybody who's asking how do I get these nice icons and the lettering on it, I've done it with the same method the PCBs are done. There's a toner transfer method. I just designed it in GIMP, or no, in another program for vector graphics, and printed it, and these are aluminum sheets, and it works like a charm. I have to put some film over it in the future, cause if there is a drop of acetone, it will fade away. But now it's very nice. It's I like it very much, so I will do it like this way again. So in conclusion, I would say I would build this project again, and what would I've changed? I think nothing. The only thing is the wire connector I would change, and it was a big fun. And next project is the Carlsons Super Probe. This is my first attempt then to do serious SMD working, and SMD with very, very tiny components. So yes, if you have any question, feel free to contact me over Patreon, and yeah, you can ask any question if you want. So have a nice day, and we will see. Bye bye.